The next Sinclair ZX Spectrum out of the repair pile is this issue 6A in a plus case. The label from Paul says, colours. The only work I've done so far is to install a composite mod using a BC549 transistor, so it's easier to get a display I can capture for you. This revision of motherboard is the final one before Sinclair upgraded the line to the 128K toast rack and is usually very reliable. The ZX8401 chip, which replaced the 4 logic chips whilst adding another one, is over here and doesn't fail too often. They're not too hard to get hold of, and there are even modern replacements you can build. If you want to see more on that, check out the video popping up in the corner of your screen, where I build a completely new one of this exact revision of Spectrum from entirely new parts, mostly, including a ZX8401. I've already tested this machine for resistance and voltages in the repair pile video over on my second channel. Go and subscribe. It's like these videos, only I don't edit all the fun out. So this should be safe to power up. And with the composite mod, we can check out the display, which is corrupted. There are a few clues here though. The white border indicates the CPU is running. The black paper appears during the self-memory test when the machine starts up. So it's basically reporting a memory error here. There are thin vertical lines evenly spaced across the screen. That will often point to a lower RAM chip being faulty. The display data is held across the lower RAM chips, and it's possible to work out which one is bad if you can spot where the vertical lines are falling. I've never been able to make that work though, and tend to use more reliable methods. Okay, so the thing I want to talk about next is capacitors. I know it's a thrilling subject and one I talk about quite a lot, but the fact is that 48K ZX Spectrums have bad capacitors, often. But before we get to that, let's have a look at what the amazing Byte Delight diagnostic cartridge has to say on the matter. The first thing to notice is the voltage LEDs are all nice and bright. I missed this on one of the other machines, which turned out to have a few bad caps in, which when replaced fixed that machine. The next thing is the result of the diagnostics, which is saying all of the lower RAM is faulty. There are a few things to consider here. Firstly, the chances of all the lower RAM going faulty at the same time are small. Certainly not impossible. I've seen it myself, but it's less likely than some of the other options. There's a chance that the capacitors have degraded to the point they're causing this whole problem by themselves. But the flip side of that is this is a later revision board and the caps are usually okay. All of the memory being reported faulty at the same time does concern me. But that could also point to a bad ZX8401. The ULA is a -7 version and those are usually very reliable. The CPU is good as it's running code. The ROM could possibly be faulty. That pretty much covers it, so where do we start? Well, the best thing to do here is to replace all of the caps with new ones. That's the most likely problem, and even if it isn't the problem, it still needs doing, so we have a reliable baseline to move forward with. I usually cut the caps out so it's easier to remove them and kinder to the board, but in this case I think I'll try to remove them whole and test them. My component tester is a handy thing, but I don't think it will be regarded as the perfect tool for the job. But it's all I have for this task, so it will have to do. Right, let's get on with it. Before I start, there's one thing I need to address. Life-size Teddy Bear, a legend from the recent charity fundraising, noticed something odd when I showed this Spectrum during the repair pile video on my second channel. Their eagle eye spotted the motherboard wobbling on the bench as I probed around checking for resistance. Plus case Spectrums don't use the centre screw hole to fix the board in place, but look what's in here. This isn't even the right size screw for a rubber key case. It's a larger self-tapper and has no place being in here. Right, capacitors. Taking components out whole can be complicated if the legs are bent over on the other side, so before I try to remove them I add some leaded solder and attempt to straighten them as much as I can. Then adding a blob of solder on top to help conduct the heat all the way through, I take my tweezers and lift one end up out of the board. The other end is easy as I can use my fingers to hold the cap, safe in the knowledge it won't get too hot. Hot? Yeah, it got quite hot. I tested this cap with my component testing device, which showed equivalent series resistance of around 5 ohms, and the capacitance in the high 20s or as high as 51 microfarads. Also, the V-loss was recorded at 12%. As I already mentioned, this is not an ideal tool and can only give a rough idea of values. But to satisfy my curiosity, I connected a new 22 microfarad cap and tested that. And the results were much more like you would expect. 24 microfarads on this new one versus 51 on the old. V-loss of 0.6% versus 12%. And 0.54 ohms ESR in the new cap, with the old one showing 5 ohms. Now I'm going to go out on a limb here and say that this old capacitor is no longer any good.
You don't say!
Starting on the right side of the board where a lot of the components in the voltage regulation circuit are, I replaced the caps one at a time, testing after each one. And with each one failing to fix the fault, I grew more nervous as I worked my way across the board. The next ones were these two 100 microfarad caps here at the bottom of the board. C45 sits between ground and the 12 volt rail, which then heads off to the video display chip. C44 does the same thing, but for the 12 volt supply for the 4116 lower RAM chips. Now I can't show this as I forgot to record it, but I did notice when checking around with my thermal camera that C44 was noticeably warmer than C45. But that could be completely normal. This cap here was the one that came out of C45, and this one came from C44. Let's test C45 first and see how far out of spec it had wandered. Quite a long way. The other one was not quite as dried up, but still far outside its expected values. I replaced both of them with brand new 100 microfarad caps, switched it on, and it works. No memory errors. I did test with diagnostics just to make sure. It was just bad caps, again. But take a closer look at that output. The quality is shockingly bad. There's some horrible interference going on there, so we're not quite done yet. The first thing to do is replace the remaining capacitors. These two on the left edge are part of the video signal generation circuit, so I'm extra curious to see if replacing those will affect the signal. But before we get to that, let's quickly talk about those dreaded caps again. And yes, I know I look like Santa's junkie brother. I caught the space lurgy and I had to go and lay down for a few days, but I'm on the mend now. Once all the caps were replaced, I went through and tested all of them. And by the way, that didn't make any difference to the output of the video signal. And every single one of them was out of its original spec in almost all regards. It might only have been the ones at C44 and C45 that were causing the computer to fail, but all of these other ones were getting towards the very end of their possible life expectancy. Not all Spectrums will have exactly the same results, with differences in how they've been stored and how hard a life they've had in terms of use, and with case temperatures cooking the electrolytic fluid, but they are all around 40 years old now. If you Google electrolytic capacitor life expectancy, this will return results that vary from 2 years, that was from someone at DigiKey talking about shelf life, all the way up to 20 years. Life expectancy is a very tricky thing to pin down with this type of component. There are so many factors that can change the result massively, from the original temperature rating to storage conditions both before and after installation, and a whole range of other variables. But one thing is sure, when Sinclair installed these, to be honest, crappy quality capacitors, they certainly didn't expect any of them to last over 40 years. It still amazes me that some of them still work just fine. So with all of these caps now refreshed and brand new, this should be a perfectly working machine with what passes for good image quality from a composite modded ZX Spectrum. And, oh, the image quality is still very poor, which is fine, at least I have something else to fix. There are a couple of other things that could be causing this. The first and easiest suspects are the pair of transistors over by the modulator, TR1 and TR2, which sit between the LM1889N chip, where the video signal is generated, and the modulator. The first thing I noticed when I inspected TR1 and TR2 was,
The hell is that?
that LM1889N chip isn't an LM1889N. It doesn't even have the same amount of legs. At first I thought I'd stumbled on something that nobody else had seen. Maybe this was an experimental chip that had never made it into production. Even more excitingly was the prospect that maybe this chip was still being manufactured today, so we might finally be able to build a 100% brand new Spectrum instead of the 99.9% ones all us clickbaity YouTubers were pretending to make. But sadly, my dreams were dashed with a quick search of the internet, where I discovered that not only was this a known chip, it was also a bad chip. The SN94459N does some of the same things the LM1889N chip does, only worse. Some of the research results stated it was known to cause colour issues, which isn't exactly what we are seeing on the screen, but I now think this could be the culprit. Happily, it's possible to remove this rubbish chip and drop a standard LM1889N in there without any further modifications. The question is, do I replace the transistors first or the video encoder chip? Press your screen now to vote. Thank you. Hooray, we're going to replace the chip. Did you press your screen? Well, that looks better already. The other chip was starting to make my teeth itch. Right, let's get this thing plugged in and see the nice crispy composite display. Oh, it still looks rubbish.
No.
The next step is to replace TR1 and TR2. To do this, I reverted to the alternative composite mod using a 100 microfarad capacitor and swapped out the transistors for BC549s. I also tested a different ULA before changing these, but that didn't make any difference. Right, how does it look now? Do you want to see a comparison from the earlier capture? Of course you do. It's a lot brighter, which is part of how this capacitor mod works with the new transistors, and the brighter image might be hiding some of the interference that I can still just about see. If you have a good idea what might be causing this, please let me know in the comments. But this machine is now good enough. No specky composite output is perfect, and this one has no gel bars, and in game it looks perfect. Compared to the RF picture on the colour portable TV I used back in the 80s, this is beyond amazing. So I'll put this one back together and move on to the last couple of machines in the 48K pile. Watch out for upcoming second channel videos, including a couple more repair pile first looks where I go through the big pile of broken machines I've got here and give them an initial test and first check over. There are some Commodore 64s, an Amiga 1200 and a big pile of ZX Spectrum Plus 2 Greys. Also, on the 11th of November, I'll be helping out my very good friend Rose Tinted Spectrum. He'll be doing a 24-hour over 2 days live stream playing only Dizzy games to raise money for Great Ormond Street Hospital. I've donated an Amiga 500, which along with seriously loads of other amazing prizes will be given away over the 2 days. My Amiga will be tricked out with a Pi Storm, kindly donated by another pal, Simon Osborne, and Rosie will be joined by a massive list of special guests including Ashens, Violet Berlin, Control Alt Reese, Neil from RMC, both Oliver twins, and best of all, me! I'll get to talk his ear off for an hour starting at 7 PM GMT, and it promises to be an amazing event. If you would like to know more, there's a link in the description that will take you to a video Rosie has made to explain the reasons behind this fundraising effort, and I can tell you they're very good reasons. Between now and then, I hope to release a video about the Amiga I'll be donating. Right, that's all for now. Bye.